Alright, so lesson 4, I'm just going to recap the rules in case you were out. It looks at enlarging or reducing area, and we have two cases of enlarging and reducing area. We have a dilation, and a dilation is where we have a shape that maybe looks like this rectangle, and to dilate it, I would grab it from the corner of the rectangle, and everything is getting bigger. All of the sides are changing proportionally. This is what a dilation would look like. Whereas a stretch, if we're dealing with a stretch, I might start with this rectangle and then stretch it horizontally by one amount and then vertically by a totally different amount. And so now I'm getting a totally different rectangle. Area is still increasing or decreasing, but we don't have the sides changing by the same amount. Now, we looked at an investigation of how that impacted area, and to sum up what happens when we are enlarging or reducing a figure by a scale factor. Well, this sentence, when you enlarge or reduce a figure by a scale factor, that means you're completing a dilation. So if you do a dilation, we know that the image and pre-image must be similar to each other, which means that all of the corresponding angles are congruent and all of the corresponding sides have to be proportional. Next, if similar figures A and B are related by a scale factor of R, then their respective areas are related by a factor of R squared. So the scale factor is R, the areas are R squared. And to sum up that rule, to get the area of an image, we take the area of the pre-image times the scale factor squared. And you saw this on the inside of the foldable, but just to kind of recap why that works. Let's say I'm starting with a box that measures 2 by 2. If I want to dilate it, well, first off, we know the area of that shape has to be 4. If I dilate that box by a scale factor of, let's just say 3, this side's going to become 3 times as long, this side's going to become 3 times as long, and now my new area is how much? 36. Now the reason the new area is 36 is because when my scale factor was 3, I'm tripling this side, which would triple the area, but then I tripled this side also. So the rule tells me if I hadn't drawn that, I could have taken the original area times the scale factor squared to get that new area. In a case like ours, if I tell you it's a 2 by 2 box, you can figure out that it becomes a 6 by 6 box and get the area of 36 that way, but we won't always be given the dimensions, and so we really need to know what that rule is and understand why that rule works. Next, we're going to look at a stretch. So when a figure is scaled by factors A and B in 2 perpendicular directions, that phrase, 2 perpendicular directions, they're just saying we're stretching it horizontally and vertically. And we won't ever deal with stretches that aren't horizontal and vertical, aren't perpendicular to each other. So if we change it by A and B, the area is going to be multiplied by AB. And we saw that on the inside of the foldable also when we were completing the investigation. So the rule is that the area of an image is equal to the area of a pre-image times the horizontal stretch And when I say stretch, it could be a stretch or a shrink, and then times the vertical stretch. To illustrate what that would look like, I might start with my same 2x2 box. It has an area of 4. And let's say I stretch it and I make it 3 times as long. 1, 2, 3 times as long, but only twice as wide. So here's my new rectangle. Well, the area is the original area times my horizontal stretch and my vertical stretch, which gives me a new area of 24. I could have calculated that my new dimensions of my new shape are 6 by 4, but we won't always have that option, and that's why we have to understand the rule that we're multiplying times the horizontal stretch and the vertical stretch. And this rule actually covers us for a dilation also. In the case of a dilation, the horizontal stretch equals the vertical stretch. And that's another reason we're squaring that scale factor, is because both of these stretches are the same. So we're multiplying by the same number twice. Things you have to look out for, sometimes instead of giving you the area of the pre-image, they give you the area of the image, so you have to work backwards.